Imagine a colossal structure defying violent winds, earthquakes, and the relentless passage of time. A bridge that not only connects cities but also stories, innovation, and extreme engineering. Today, you will uncover the secrets of the iconic Golden Gate Bridge and how it became one of the greatest engineering feats in the world. The Golden Gate Bridge is one of the greatest symbols of modern engineering and a true architectural landmark spanning the San Francisco Bay in California. Inaugurated on May 27, 1937, this iconic structure, nearly 3 kilometers long, not only revolutionized connectivity in the region but also pushed the limits of engineering at the time. Before its construction, the only way to cross the bay was by ferry, which made transportation slow and inefficient. With the growing demand for a faster connection between San Francisco and Marin County, the need arose for a bold and innovative project that could overcome the region's strong currents, intense winds, and deep waters. Initially, many engineers believed that building a bridge there was impossible, but the visionary Joseph Strauss, the project's chief engineer, proved that it was possible to erect one of the greatest feats of civil engineering in history. The structural functioning of the Golden Gate Bridge is a true example of innovation and resilience. It is a suspension bridge, supported by 2 massive main towers standing 227 meters tall, with approximately 20 meters submerged underwater. The main cables, composed of more than 27,000 strands of braided steel, are responsible for sustaining the entire structure, bearing a colossal weight of approximately 887,000 tons. The bridge has a central span of 1,280 meters, making it the longest suspension bridge in the world at the time of its inauguration. The project also had to address seismic challenges, as the San Francisco Bay Area is located over active geological faults. To ensure its resistance to earthquakes, advanced seismic damping technologies have been incorporated over the years, allowing the bridge to adapt to oscillations without compromising its structural integrity. Additionally, the Golden Gate Bridge undergoes constant maintenance to combat the corrosive effects of ocean salt and humidity, requiring frequent repainting to preserve its iconic red-orange color, known as International Orange. The construction of the Golden Gate Bridge was one of the most complex engineering challenges of the 20th century. Beginning in 1933, the project involved thousands of workers facing extreme conditions, such as winds exceeding 90 kilometers per hour, dangerous tides, and dense fog that frequently obstructed visibility. To ensure worker safety, a massive safety net was installed beneath the bridge, saving the lives of 19 workers, who became known as the Halfway to Hell Club. However, the construction also saw tragedies, with 11 workers losing their lives due to falls and accidents. The project's innovative engineering included deep underwater foundations, using pneumatic caissons to allow excavation on the ocean floor. The concrete and steel anchorage blocks were designed to withstand extreme forces, ensuring the structure's stability over the decades. In less than 4 years, the Golden Gate Bridge was completed, becoming a global icon and a testament to the power of human engineering. Beyond its impact on mobility, the Golden Gate Bridge brought immeasurable economic and social benefits to the region. The quick connection between San Francisco and Marin County spurred urban and industrial growth, facilitating the transport of goods and promoting tourism. Millions of visitors from around the world come each year to admire its architectural beauty and photograph its breathtaking panoramic views. Furthermore, the bridge plays a fundamental role in transportation infrastructure, connecting major highways and enabling an efficient flow of vehicles between neighboring cities. Its elegant and imposing design has also inspired countless other structures worldwide, solidifying its significance in the history of architecture and civil engineering. The environmental impacts of the Golden Gate Bridge have been carefully analyzed over the decades. Like any major infrastructure, its construction partially altered the local marine ecosystem, but measures were taken to minimize damage to the region's fauna and flora. Over the years, the bridge's management has implemented sustainable actions to reduce its ecological footprint, including energy efficiency programs and maintenance practices that use recyclable and less polluting materials. For example, the bridge's lighting has been upgraded to reduce energy consumption, making it more efficient and environmentally responsible. Additionally, the Golden Gate remains a crucial point for climate monitoring in the region, providing important data on winds, tides, and atmospheric conditions that support scientific studies and environmental preservation efforts. Despite its grandeur, the Golden Gate Bridge faces constant challenges, ranging from the impacts of time and corrosion to the need for modernization to handle increasing traffic. Structural reinforcement projects and technological improvements are continuously implemented to ensure its longevity. One of the most pressing recent challenges is adapting the bridge to withstand even more intense earthquakes, given that California is prone to high-magnitude tremors. Studies indicate that additional reinforcements may be necessary to guarantee its stability in the event of future seismic activity. Moreover, the growing number of vehicles and tourists crossing the bridge daily imposes continuous demands for maintenance and expansion of the surrounding roadway infrastructure. The construction of the Golden Gate Bridge not only overcame technical challenges but also faced significant financial obstacles. Initially, the project was budgeted between $17 and $35 million, amounts that, adjusted for inflation, would equate to approximately $750 million today. The Great Depression made fundraising difficult, but through the issuance of municipal bonds and support from the local community, the necessary resources were obtained, allowing construction to begin in 1933. In addition to financial challenges, building the bridge required innovative solutions to ensure its stability and durability. Engineers designed the structure to withstand winds of up to 160 kilometers per hour, incorporating elements that allowed flexibility and energy dissipation. The choice of international orange color was not only aesthetic, it also improves the bridge's visibility in the frequent fog conditions of the region, enhancing safety for navigators. After its inauguration in 1937, the Golden Gate Bridge became a cultural icon and a symbol of progress and innovation. Its presence profoundly impacted San Francisco's identity, appearing in films, photographs, and artworks worldwide. The bridge is not just a transportation route but also a monument that celebrates human ingenuity and the ability to overcome seemingly insurmountable challenges. The future of the Golden Gate Bridge remains promising, with ongoing investments in its preservation and modernization. The bridge stands as a symbol not only of innovation but also of resilience and progress. Whether for its structural magnificence or the impact it has had on society, the Golden Gate remains one of the greatest marvels of civil engineering. Its legacy lives on, inspiring engineers, architects, and dreamers around the world to push boundaries and turn bold visions into reality. New technologies are being incorporated to ensure that the Golden Gate Bridge remains safe and functional for many decades. State-of-the-art sensors continuously monitor its structural integrity, detecting any signs of wear, abnormal vibrations, or corrosion before they become critical issues. Additionally, advanced studies in durable materials and seismic reinforcement techniques are being applied to protect it against the frequent tremors that affect California. These advancements ensure that the bridge continues to play its essential role in the mobility and tourism of the San Francisco Bay Area. Beyond safety and durability, environmental initiatives are also part of the Golden Gate's future. Projects aimed at reducing the bridge's environmental impact include new solutions for corrosion control, minimizing the use of harsh chemicals, as well as research to improve its energy efficiency by incorporating LED lighting and renewable energy sources. Moreover, its significance extends beyond engineering. The bridge remains a cultural and tourist symbol, attracting millions of visitors who seek to admire its beauty and experience the grandeur of this structure that has made history. Looking ahead, the Golden Gate Bridge is not just a landmark of the past but an example of adaptation and evolution. Its history proves that, with innovation and dedication, it is possible to preserve great engineering achievements without compromising their identity and functionality. Thus, the Golden Gate is not merely a bridge connecting cities, but a link between generations, a living testament to humanity's ability to overcome challenges and create something truly extraordinary.